Hey, it's Mr. Stoletano here, and today we're going to talk about elements, compounds, and other new chemistry vocabulary. So some of the new vocab we'll be looking at: chemistry, matter, macroscopic, submicroscopic, mass, element, compound, and pure substance. So firstly, what is the science that investigates and explains the structure and properties of matter? What are we taking this year? Chemistry. What about anything that takes up space and has mass? So this one you probably heard before. This one is matter. So matter, in order to qualify as matter, you have to take up space and you must have mass in order to be matter. If you take a minute to look around the room, most of the things around you will be matter. If you look around, most things will be considered matter. But what kinds of things aren't considered matter? So they have to have either not have mass, not have volume, or not have either. So for example, heat is not matter, light is not matter, thoughts are not matter, radio waves and magnetic fields are not considered matter because they have to take up space and they have to have mass, and none of those things have both of those. So what about how much matter or stuff an object contains? What would you consider that? So that is actually mass. Now, what's really important at this part of the video is we want to discuss the difference between mass and weight. Now, mass, as we just said, is how much matter or stuff is inside an object. Weight is actually the force of gravity on an object. Now, what's important about that is that weight will change depending on your location. So, for example, if we look in the images over here, these people are doing a gravity simulation and this person's on the moon, right? So on the moon, your weight will be very different than it would be on Earth. But your mass would not change from Earth to the moon no matter where you are. So most important difference, your weight fluctuates with location because of gravity. And your mass will not change no matter what happens to gravity. Your mass will stay consistently the same. So that's a key thing, because mass is how much is inside you. How much is inside you will not change depending on where you go. So keeping that in mind, where do you have more mass, would you say? On top of a mountain or at sea level? So think about it. Where would you have more mass? Think hard about that one. A couple other vocab terms. So one is macroscopic. So for something to be macroscopic, it's your normal view of the world. It's what you can see with your unaided naked eye, essentially. That is macroscopic. So for example, this is the graphite from a pencil, so this is not lead, this is graphite. And this is what you can see from it from your naked eye. You can tell it's, relatively shiny, it has a gray color. These are things we can determine that way. So those are macroscopic observations about this graphite. At the submicroscopic level, let's think about that word. Sub is the first part of it, meaning below the surface, right? So below essentially is sub, and then microscopic meaning microscope, right? So for something to be submicroscopic, that would have to mean that it is below the microscopic level. So this is what we consider the atomic level. This is actually what you can't see without a standard light microscope. I'm sorry, with a standard light microscope, you still can't see this. This would be considered the atomic level. So if we were to zoom in on that graphite on the pencil, this is what we would see. These are the atoms that comprise the graphite, which are carbon atoms. Now, elements. So this is one of the most important parts of this unit that we'll be discussing. Elements are made entirely of one type of atom. That's what defines an element. So the whole thing is made of one building block and one type of atom. So for example, the metal gold, Au, is made entirely of pure gold element. And it's just one element. So here's gold, and it's made entirely of gold atoms. If you were to examine every atom that makes up gold, they're all gold atoms. They're all what makes it an element, because they're the same type of atom. Diamond is considered an element because it is made up entirely of the element carbon. So that makes diamond an element. I'm sorry, one type of atom, which is carbon atoms. Aluminum, which is in aluminum cans you drink soda from, that is also considered an element because aluminum is made entirely of a single type of atom. And here's the symbol for aluminum, Al. Now, what we were just looking at, that's the macroscopic view of an element, right? We can see this with our naked eye. This is the submicroscopic view of the element. If you look at each of these samples, this is them zoomed in thoroughly to the atomic level, essentially. This is the submicroscopic view. And what's interesting about this is that if you look, all of these are made up of the same type of building block, which is what makes them an element. But if you look at them, they have more than one of that atom. So people tend to get confused. Remember, an element is just one type of atom that makes it up. So these are all made of multiple atoms, right? You see multiple orange atoms, multiple black atoms that make up this moving structure. And you see multiple blue atoms here. But the important thing that makes it an element is one type. You can have as many as you want, but it's one type. That's what makes it an element. Compounds. So a compound has to have at least two types of atoms, and they must be chemically bound to each other for this to qualify. So the most famous compound that you've heard of is NaCl, which is salt, right? Table salt. If we look at the submicroscopic view over here, it's made of one atom of sodium and one atom of chlorine. So we have our two types of atoms. It fits the requirement. This is now a compound. Here's our macroscopic view of salt. So this is if we zoom back out. And again, salt is a compound. Here is the submicroscopic view of different compounds. Here's water, made of two types of atoms, right? Hydrogen and oxygen. Sample B is also a compound. We have red and blue present, so we have two types of atoms there to think about to make it a compound. Here is formaldehyde, which actually is made up of hydrogen, carbon, and oxygen. Fits the requirement because it's at least two types of atoms, so that is going to be a compound as well. You can have as many types of atoms as you want to make a compound, as long as there's at least two. And one of the most important things is they must be chemically bound to each other. So notice these are bound, those are bound, and those are bound. That's what makes it a compound. Okay, so what are some cheat sheet things to help us remember elements and compounds? Elements are considered one thing or substance, right? That's what makes it an element. They're found on the periodic table, so it's the periodic table of elements, right? So if you can find it there, it must be an element. That's one way to know for sure. If you see one capital letter, that makes it one element. So every type of atom in a chemical formula will have a one capital letter in it. So if your formula is made of three different types of atoms, you can expect to see three different capital letters present. And that wouldn't be an element anymore, right? Because you have to have only one capital letter present to make it an element. For compounds, there's still one thing all the way through, still one substance. So it's still uniform. That's what these two have in common. But that one thing is made of more than one type of atom. The formula is usually also given for a compound because you have to know the formula to know if there's more than one type of atom present. And they're also typically not found on the periodic table. They're never found on the periodic table, in fact, because it's not the periodic table of compounds. It's the periodic table of elements, right? So that is how we help distinguish between the two. Alright, so take a minute to try to figure these out. Are we dealing with an element or a compound? Salt, NaCl, compound. Sugar, compound. Look at those three different types of atoms in the formula. Oxygen. Oxygen is an element because it's O2. That's the formula. There are two oxygens, but it's one type of atom present. Chlorine. There's two chlorines, but it's one type of atom present, so that is a element. And finally, water. Water's formula is H2O. That would be a compound. Okay, and the last part of this video that I want to make sure we understand is what a pure substance is. So pure substances are made of either all one compound or all one element. They're thought of as one single thing. So there's nothing else mixed in there. So number one is an element because it's made purely of this type of atom, which is yellow. And number two is a compound because it's made of each of these, but it's uniform. Each one has one green, one red. That's what makes it a compound. So two types of atoms here, one type of atom there. Pure substance and still a pure substance. Okay, so quick vocabulary review. The amount of matter in an object, what would you consider that? That would be mass. Can be viewed by the naked eye. Which of these words on the right would that be? That would be macroscopic. comprised of a single type of atom, that would be element, and comprised of at least two types of atoms, that would be a compound. Anything that takes up space and has mass would be matter. And then to view something at the atomic level, that would be submicroscopic. So that does it for us today. Thank you for listening and watching. And remember, chemistry is everywhere.